Discussing sets. What do you mean by set? A set is a well-defined collection of objects. Objects in the collection are called elements of the set. Examples: the collection of persons living in Makati is a set. Each person living in Makati is an element of the set. Another one, the collection of all cities in Metro Manila is a set. Each city in Metro Manila is an element of that set. Another example, the collection of counting number is a set. Each counting number is an element of that set. We have the set notation. Sets are usually designated with capital letters. Elements of a set are usually designated with lowercase letters. Elements of a set are enclosed with curly braces. There are two ways of describing a set. First is the roster method of specifying a set consists of surrounding the collection of elements with braces. Examples: the set of counting numbers from 1 to 5 would be written as, in closed curly braces, we have 1, 2, 3, 4, and 5. A variation of the simple roster method uses the ellipsis when the pattern is obvious and the set is large. Examples: a set which consists of 1, 3, 5, 7, and so on till 9,007 is the set of odd counting numbers less than or equal to 9,007. Another example, a set 1, 2, 3, and so on is the set of all counting numbers. Another way of describing a set is the set builder notation, which has a general form of a variable, a vertical bar, and a descriptive statement. The vertical bar is read as such that set builder notation is frequently used when the roster method is either inappropriate or inadequate. Examples: a set of x such that x is less than 10 and x is a counting number. It is a set of all counting numbers less than 10. It is the same way as saying a set of 1, 2, 3, 4, 5, 6, 7, 8, and 9. Another example, a set of x such that x is a fraction whose numerator is equal to 1 and whose denominator is an even number. The set builder notation will become more concise and precise as more information is introduced. We also have to discuss Venn diagrams. It is frequently very helpful to depict a set in the abstract as the points inside a circle or any other closed shape. We can picture the set A as the points inside the circle. Take a look with that figure. We also have to discuss the basic terminologies. First, what is an empty set? A set is said to be empty if it has no elements and it can be designated with the symbol null set. Example, the set of even prime numbers greater than 2 is an empty set. Another example, the set of x such that x is less than 3 but is greater than 5 is an empty set. We also have to discuss subset. A set A is said to be a subset of set B if every element of A is an element of B. If A is a subset of B, we can write that A with the symbol of subset B. That is to designate the relationship. If A is not a subset of B, we can write A, the symbol of not a subset, to B. That is to designate again the relationship. Example, set A is equal to 1, 2, 3 is a subset of set B, which is equal to 1, 2, 3, 4, 5, and 6, because each element of A is an element of B. We can write that as A is a subset of B to show the relationship between A and B. We can also write the elements. A set of 1, 2, 3 is a subset of 1, 2, 3, 4, 5, and 6. We have another example. We must notice that B is a subset of A because every element of B is an element of A. We also have what we call equal set. Two sets A and B are equal if A is a subset of B and B is a subset of A. We can denote that A is equal to B. Example, set A is equal to 3, 4, and 6, and set B is equal to 6, 3, and 4. Sets A and B are equal because A is a subset of B and B is a subset of A. The definition of equality of sets shows that the order in which elements are written does not affect the set. Another example, sets A is equal to 2 and set B is equal to 2 and 5. Sets A and B are not equal because B is not a subset of A. And we can write that A is not equal to B. But we have to know that A is a subset of B. Another example, set A is equal to X such that X is a fraction and B is equal to X such that X is 3/4. Sets A and B are not equal because A is not a subset of B. We can write that A is not equal to B, but we have to notice that B is a subset of A. We also have what we call intersection of sets. The intersection of two sets A and B is the set containing those elements which are elements of A and elements of B. It could be written as A, the symbol for intersection, and B. Example, if A is equal to 3, 4, 6, and 8, and B is equal to 1, 2, 3, 5, and 6, then A intersection B is equal to 3 and 6. Another example, if A is equal to A, B, C, D, E, F, G, H, I, and B is equal to A, C, E, G, I, K, M, then A intersection B is equal to A, C, E, G, and I. Another example, if A is equal to Maria, Pedro, Juan, Martha, Pablo, Jose, and Andres, and B is equal to Pedro, Jose, Andres, and Martha, then A intersection B is equal to Pedro, Martha, Jose, and Andres. We also have what we call the Venn diagram. It is the graphical representation of a set. Set A is represented by the red circle, and B is represented by the blue circle. When B is moved to overlap a portion of A, the purple colored region illustrates the intersection of A and B. to have what we call union of sets. The union of two sets A and B is the set containing those elements of A or elements of B. We can write that as A, the symbol for union, and B. Example, if A is equals to 3, 4, 6, and B is equal to 1, 2, 3, 5, and 6, then A union B is equal to 1, 2, 3, 4, 5, and 6. Another one. If A is equal to A, C, D, G, H, J, and set B is equal to B, C, D, E, G, H, then A union B is equal to A, B, C, D, E, G, H, J. Another example. If set A is represented by the red circle and B is represented by the blue circle, the purple colored section illustrates the intersection. The union consists of all points which are colored red or blue or purple. That ends our lesson for today. Thank you for watching. See you around. Uy, hindi pa! Uy, edit mo na lang yung Raquel.